In a single 30-day window, an AI model crossed 10 trillion parameters and was locked in a vault. A rocket company bought an AI lab for $250 billion in cash. A mathematical breakthrough cut the cost of running large models by 80%. It has become a high-stakes component of global physical infrastructure. In early April, Anthropic confirmed the existence of Claude Mythos 5. It has 10 trillion parameters, the adjustable connections inside the neural network. For context, GPT-3 had 175 billion. Mythos 5 is 57 times larger. It uses a mixture of experts design. Like a hospital routing a heart patient straight to a cardiologist, Mythos 5 houses 10 trillion parameters, but activates only 1 trillion per question. You get massive depth with the speed of a smaller model. But Anthropic did not release it. They assigned it a safety classification called ASL4 because the model demonstrated capabilities in cybersecurity, bioweapons reasoning, and autonomous research that does not require a human in the loop. The safety lockdown indicates that the model reached autonomous behaviors that Anthropic's own researchers didn't expect to see for several more years. SpaceX acquired xAI for $250 billion in cash and stock. This wasn't a standard tech acquisition. SpaceX builds the most complex physical infrastructure on Earth, from reusable rockets to 7,000 satellites in orbit. These projects generate more data than human engineers can process. SpaceX bought xAI because their hardware needs autonomous intelligence to manage these systems at scale. In this quarter alone, Amazon led an OpenAI funding round with $50 billion. NVIDIA put in 30. SoftBank added another 30. Total venture deal value for AI hit $297 billion in 90 days. Capital is being concentrated into a few massive compute clusters, which are now being integrated directly into factories, energy grids, and defense systems. While models got bigger, Google research focused on efficiency. They published a paper on an algorithm called TurboQuant, which reduces the memory footprint of running these models by a factor of 6. The bottleneck is the KV cache, the working memory that an AI builds as it reads your prompt. As this diagram shows, for long conversations or deep code reviews, that memory buffer fills up until the system slows down and consumes massive amounts of energy. TurboQuant solves this by rotating the data vectors before compression, making them easier to pack together. Combined with a single bit error checker, it shrinks the working memory to 1/6 its size. If it costs 6 times less to run a model, products that were once too extensive, like real-time voice agents or autonomous legal review, become viable overnight. The competitive edge in this market is moving away from raw computing scale and toward the labs that can compress intelligence the most efficiently. These efficiency gains have immediate human consequences. Snap's decision suggests that for many firms, the incentive has moved from using AI to assist employees to using it to replace their roles entirely. But there is a massive liability in trusting these models without verification. The Nebraska Supreme Court recently suspended an attorney named Greg Lake after he submitted a brief with 57 defective citations. 20 of them were fabricated by a chatbot, fictitious cases and statutes that simply do not exist. This is part of a broader pattern where professionals in law, medicine, and finance are outsourcing factual verification to systems that cannot distinguish between a real citation and a hallucination. As courts and regulators increase sanctions, the winning models won't necessarily be the smartest, but the ones that can prove their facts and admit when they lack the answer. In late March, NVIDIA released a specialized AI model called Icing. It was built for one specific purpose: to accelerate quantum computing. Quantum computers are notoriously fragile. Even a tiny vibration can cause a calculation to fail. Solving this requires error correction, the ability to recognize and fix microscopic deviations in real time. This is exactly the kind of pattern recognition problem AI is designed to solve. Icing provides error correction that is 2.5 times faster and 3 times more accurate than traditional methods. Major institutions, including Harvard and Lawrence Berkeley National Lab, have already adopted this technology, forcing the artificial intelligence and quantum timelines to converge. This convergence creates a direct threat to the cryptography that secures the digital world. The mathematical locks used by banks, national security systems, and Bitcoin are all vulnerable to a stable quantum computer. Research from Google suggests that breaking Bitcoin's encryption could require 20 times fewer quantum bits than we estimated just a few months ago. AI is now actively building the hardware that will challenge the foundations of digital security. The next video on this channel is a head-to-head comparison of every flagship model: Claude 4.7, GPT 5.5, DeepSeek V4, and Gemini 3.1, to show you the specific benchmarks and use cases where each one wins. Subscribe so you don't miss it.